Hi everyone, welcome to Python code Nemesis. Today we'll be going over linked lists in Python and some of the very common misconceptions and mistakes that we developers or students make when we are using stacks and queues initially, especially when you're using it for programming contests in Python. In Python, a linked list can be implemented using a class with each instance of the class representing a node in the list. Each node has a reference pointer to the next node in the list as well as a value. The last node in the list has a reference to node indicating the end of the list. Linked lists have advantages over arrays when it comes to inserting and deleting elements, as the elements do not have to be shifted in memory. However, they have slower random access times. For Python interviews, you are generically assessed on your ability to use data structures. You don't need to implement stacks and queues from scratch. Now, in C++ and Java and other languages, there are utility libraries which help implement these stack queues and priority queues of type node object. That is not an array, but of a linked list with actual nodes in it. Do we have inbuilt modules in Python to use stacks or queues, or do we use a list? What are the time complexities for general operations for search and insert? These are some of the questions you will find answers to in this article. Using Collections.deque for queue. The collections module in Python provides a deque, a double-ended queue class that can be used as a queue. A queue is a data structure that follows the first in, first out principle, where the first element added to the queue will be the first one to be removed. To use a queue with the collections.deque, you can create an instance of the deque class and use the append method to add elements to the queue and the pop left method to remove and return the first element from the queue. Here's an example of how to use a deque as a queue. So why are we doing pop left? Because we are appending from the right, we pop from the left so that we have the first in, first out principle working. So this is the small code. So from collections, import deque, create a new deque, append apple, banana, and cherry, and then pop left. So the first one to be popped from the left will be apple, and from the next one will be banana. You also use append left for adding element at left and pop for removing element from right. So in case you want to be appending from the right and inserting from the left, which is generically what we do, then you can use append left to add an element at the left and pop to remove element from right. Note if we try to use pop left method or an empty queue, it will raise an index error. So this is what needs to be handled when you're actually using this in a real life scenario or as well as an interview. Time complexity. When using the collections.deque as a queue in Python, the average time complexity of the main operation enqueue and deque is big of 1 on average. This means that the time it takes to perform these operations on an average does not depend on the number of elements in the queue. The append and pop left methods of the deque class are implemented as big O of 1 operations, which means that they take a constant amount of time regardless of the number of elements in the queue. This makes the deque efficient for use as a queue since both the enqueue and deque operations have a big O of 1 time complexity on average. However, it's important to note that in the worst case scenario, the time complexity of pop left operation on the deque object is big O of n because it is implemented as a cyclic buffer. So if we constantly add elements and remove elements from one end, the buffer will be reallocated every time it becomes full, and this operation can be costly. In summary, using collections.deque as a queue in Python can have a 0 big O of 1 time complexity on average for both enqueue and deque operations, making it an efficient data structure for queue operations, but in the worst case, the time complexity could be big O of n. Comparing time complexity with list. When using a list in Python as a queue, the time complexity of the main operations NQ and DQ is big O of 1 for NQ and big O of n for DQ. This means that the time it takes to add an element to the queue, NQ, is constant and does not depend on the number of elements in the queue, but the time it takes to remove the first element from the queue is linear and depends on the number of elements in the queue. On the other hand, when using Collections.deque as a queue in Python, the time complexity of the main operations NQ and DQ is big O of 1 on average. This means that the time it takes to perform these operations on an average does not depend on the number of elements in the queue. It's worth noting that when a list is used as a queue, the DQ operation is big O of n, because it requires all the elements after the first one to be shifted down by one position. Therefore, when compared to using a list as a queue, using Collections.deque in Python is more efficient in terms of time complexity, as both the NQ and DQ operations have big O of 1 time complexity on average. Using Collections.deque as a stack, the collections model in Python also provides the same DQ class, which can be used as a stack. A stack is a data structure that follows the last in first out principle, where the last element added to the stack will be the first one to be removed. To use a stack with Collections.deque, you can create an instance of the DQ class and use the append method to add elements to the stack and the pop method to remove and return the last element from the stack. Here's an example of how to use the DQ as a stack. From collections, import DQ, stack equal to DQ, add apple, banana, and cherry. When you pop the stack, it prints cherry and then banana. So the latest element was popped the first. Alternatively, you can use the append left methods to add elements and pop left method to remove and return the first element. So either append right, pop right, append left, pop left. There's no pop right or append right as well. It's just the generic append and pop is always from the right. So if you again try to use the pop method or an empty stack, it'll try to raise an index error. Time complexity. When using the Collections.deque as a stack in Python, the time complexity of the main operations push and pop is big O of 1. So it does not depend on the number of elements in the stack. So both the append and pop operations have been implemented as a big O of 1 operations. Similarly, append left and pop left also has a complexity of big O of 1 as well. So using Collections.deque as a stack in Python has a big O of 1 time complexity for both the push and pop operations, making it extremely efficient for stack operations. So there's no built-in isEmpty function for the Collections.deque class in Python, specifically for checking if the stack is empty, which is the case in a lot of other languages. So Collections.deque has a built-in len function that can be used to check if the stack is empty. If the length of the DQ is 0, it means the stack is empty. You can use if not stack or if len equal to stack to check if the stack is empty. You can also use the bool function to check if the stack is empty, which returns false if the stack is empty and true otherwise. In summary, although there is no specific built-in function for checking if the stack is empty, it can be determined by checking the length of the Collections.deque object by using the bool function. For time complexity, the bool function is big O of 1 time. The len function is also big O of 1 time. So the time complexity for checking if the stack is empty is big O of 1 time. Great, that was it. Thanks for reading this article. Thanks for watching this video. Would love questions and feedback in the comment section. Please follow us if you like this video and subscribe if you want more videos on Python. This is, again, exploring a lot of new and existing things that Python has, things that we miss out on generically. So yeah, thanks for watching and happy coding.